So I'll be talking about few things. One is open repository, data repository, which is registry open data AWS, and I'll be talking about Python and Conda, mainly about Mamba Forge, so that we can understand how do you run a few libraries which are platform independent. And then I'll be talking about black marble dataset, NDVI, how to calculate NDVI, and earthquake data as well for India. Okay, so before we begin, I think I should tell everyone to install Mamba Forge. So if you're running Windows machine, or if you're running a Linux machine, or if you're running Mac, no matter what, but you have to download Mamba Forge. So to do that, what you could do is you could go to this website Mamba Forge from Conda Forge. So all you have to do is go to this website and then click on these links. So suppose I have a Linux machine. So what I need to do is go and download this. So say I download it. So this file will get downloaded. It is similar to what you might have done, which is Anaconda. So Anaconda also has the same features what Mamba Forge has. So basically you download Anaconda, and then Anaconda has built in a lot of libraries which are installed. But what it Mamba Forge does is it only installs very few libraries or none, but only installs Python for you. So on top of that, you can install a lot of libraries. So once you have this file downloaded, say in Windows you download this, there's a pop-up that you could open up. In my case, I can't open this. So here I can't open this in Linux. In Linux, you have to run from terminal. But in Windows, what you could do is something like this. So go to Windows. So there's this graphical installer that you could install, which will give you step-by-step process on how to install Mamba Forge, not Anaconda. If you try to install Anaconda, the shape size is very large. So once you install that, just the one simple process to just activate it. So why are we doing it? We're doing this to install few libraries that Python requires to run a GeoPython, or more formally to speak, to install few libraries which are very hard to install in Windows. So you could actually do conda activate and then name of the package, name of the environment that you're creating. So something like that. Once again. Okay, so I do one thing. Okay. So the first thing, if you are running a laptop, what I want to do is create a new environment. So first thing I want you guys to do is create a new env in Conda. So everyone should learn this. Whenever you are working with geo libraries of Python, or if you're working with Python in general, try using an environment, a separate environment. And the first thing you have to always do is go to this page and then create a new environment with commands. So always do this, and then try doing this. It says that you have to create a new environment, which is conda create name and the name of your environment. Environment is basically a separate on your system itself. Maybe you have installed Python, and which is version say 2, which is very old version. Now if I try to install some other library, it might conflict. So I say that it is not compatible with the previous version. So what you should actually do is create a separate place for a new Python, so that whenever you are installing other libraries, it does not conflict. So in the same case, what I would do now is and in my case I won't use conda, but I will use Mamba. Now, why am I using Conda versus Mamba, and what is going on with all of this? So, Conda and Mamba are few things are both the same. There is no change. Only difference is Mamba is faster than Conda. Then why are people still using Conda? Because Conda is older version. People are yet to realize that there is a faster version for that. So what I'm showing right now is the faster version. So you just have to do Mamba create the name of your environment. In my case, I'll type in IEEE new environment, IEEE ENV. Too many E's. Okay, so if I run this now, I'll get the latest Python installed on this environment. So if I run this, here you can see it automatically created a new environment for me. When I ran this Mamba create new env, it showed me that there is this new environment that you can activate just by running Mamba activate environment. So I just need to run this, and because I already had one environment which was here on the left side, I had to deactivate it. Now what I'll do is I'll activate IEEE ENV, which is a new environment that I created. Okay, so this is the environment that I created just now. In this, there are no libraries installed apart from Python. So if I just type Python, it should. Okay, so if I type Python 3, it will work. And just a minute. Should have Python. Yeah, for some reason it did not install Python. So that is the ideal case. What should have happened? What I'll do is I'll run it again. Uh, so I'll run it again. Now if you see, there is clean slate, so there is nothing currently running. If you just see your terminal also, it should be on the same page. Now if I try to run Python, it should not work because I'm not currently installed, currently under any environment. So what I need to do is I need to run Python 3, then I'll be able to run one Python, which is system Python. Other thing I want to do is I have to run conda create name, and say I'll give a new name IEEE GRSS. Okay, so it is now. So what I'm trying to do here is I'm trying to create a new environment. So my bad. So previously what I had done was not correct. This is the correct way to do it. You just have to type conda create and the name of your environment. So that way now it will work. What you have to do is conda activate IEEE GRSS. Cool. For some reason it is not installing Python. Anyway, we can install Python now. What I'll do is I'll go ahead and showcase. Maybe there's some issue with the way I'm doing it, but ultimately what you want to do is create an environment. So in my case, I've created this GeoEnv environment which is freely using it. Once that is activated, I should be able to run Python in that. So that is our ultimate aim. Okay, so hope it is visible. So now once Python is installed, you have to install several libraries in this. So the famous libraries that we're going to use right now are GeoPandas, Shapely, Rasterio, Xarray, Dask, and GDAL. So GDAL, there's some different way to install, but GDAL also is GDAL comes inbuilt if you install GeoPandas. So these are the main libraries that we're going to use. To install them, what you could do is you just have to type mamba install -c conda forge and then the name of the libraries that you want to install. So how do I know this command? So the best way to know is just go to this page and type conda install geopandas, and it will take you to one of the links which is on top, and on this top link you can actually see the installation for the package. So here it says conda install -c conda forge and the package name. Here -c conda forge is the channel that you're downloading. So there are many channels under which each library comes. For geopandas, and most trusted is conda forge. So whenever you're trying to do, if you get -c conda forge, then it is a trusted source of download. So you could actually run this, and if I run this, I think let's try running. Let's see what happens. So as you can see, I have these libraries installed. So it should just say that requirement satisfied. But let us see what it says. Here you can see that because I'm in an environment, it is pinned to my package. So I have this Python installed 3.9, and it is trying to find that. So it is saying that it can't be installed because I have it is aborting operation because it's found some conflicts. But if I run Python here and import geopandas, so installing the libraries is the hardest part, and after that it is quite simple to run commands because geopandas provides those functionality. So the way you run these commands is just by importing one liners. Say you want to import geopandas, you just do geopandas as gpd. You want to import rasterio, you could do rasterio as rayo. You want to import GDAL, you can do from osgeo import GDAL. So it is that simple. And if it is very difficult for you to say set up all of this, because I myself have been in such situations, what you could do is go to your browser and type collab.research. So here I think it is quite easy for anyone to set up their environment. So even now we'll try to actually run a lot of things in Colab so that I can share the link to notebooks as well. Okay, so say I want to like run GeoPandas here. Now this online environment won't have GeoPandas installed because I haven't done that. So it is telling me that there is no module named GeoPandas, you have to install it. So the way I install it is just do pip install GeoPandas. And then I pass a flag saying -q, which says that just do it quietly. So this way, now it is installing the package. All right, so installed it package. Now if I try to run GeoPandas as GPD, it will be able to run it. Right, so it is that simple. If you find all of this hard, just all you have to do is just all install all the packages that you require. Say you require GeoPandas raster X-ray, you need Rio X-ray. Don't worry what all these libraries are doing if you are new for the first time. But say these are one of the most famously used GIS packages in Python. All right, so this is the first step that I want to cover, which is installing Python and Conda. Now, what I want to do is, so any questions on that, feel free to ask, like how do you install all of that. I want to move to important topic is, suppose you're now going for the hackathon, where do you get your data from? So a lot of, even when I participate, the question is that I want to download certain data, but I'm not able to find it. What is a good source, rich source, and easily downloadable source? So one of the sources for geospatial data, because it is very rare to find that, is registry of open data on AWS. What you could do is here go to the dataset and just type geospatial. And when you type geospatial, you'll find a lot of data. Give an example, you'll find Sentinel-2. And if you ever worked with AWS data, it is very easy to download. I'll just show you how to do it using Python. So you have Sentinel-2, you have Landsat, you have NASA prediction of world energy and resource, geostationary world cover if you want to do that. SpaceNet has very high resolution data which is available for free. They use for computer vision tasks. And then you also have, so there are tons of data available here. RadarSat, which is SAR data, you find it here. So a lot of data is available for any of the tasks that you want. If you're still searching for data that you couldn't find, just reach out. But hopefully there is some data, but your problem statement should not change based on data. Try to avoid that. All right, so there is LiDAR data as well. If I click on any of these, say there is this Capella space, which is the recently launched satellite. So what Capella has done is they have launched 30 centimeter or 50 centimeter SARS data openly under CC4, so you can actually use for commercial purpose as well. So here, if you go to tutorials under this, you'll actually find tutorials on how to use this data. And they have Python SDK. So just like a package, you have a Capella package which allows you to download the data. Now, why am I telling it is so easy on this registry is because if I just go here and I can actually just type in the command which was present here, which is AWS CLI command on the right, and if I press enter, I should be able to see the data. So you see here, this is all the data that they provide, and it is so easy to access this. So on the bucket, on the cloud, they have this one bucket where they have stored the data, and I'm actually able to see what all data it is there. So if I query this data under TileDB, they have saved all these data, so it is very easy to access. So there is one portal that you could go to for data access. I'm just going over through so that you know that this exists, and we can discuss later if you want to access using Python. Now what I want to do is I want to demo a few things which will be helpful for you in your project, which is I have two notebooks and two examples. I have, okay. So one is earthquake data. I want to showcase how do you run Kepler GL. So those of you are not familiar with Kepler GL, if you just see beautiful maps, Kepler GL, and see the images. So all these kind of beautiful visualizations actually you can do, and for you to win the competition, this is another great platform to submit, say, to visualize. QGIS is always there, but if you want to try something challenging or interesting, there's another option as Kepler GL, along with various other options. I've chosen Kepler because I like it. So I'm going to show you few Earth. So the ultimate aim, what I want to show you is this. So this I've already run the notebook, and in this small little toy example, I wanted to show where all earthquakes have happened in the last 1 year. So here, if you see, so there's an India map, and then in India map you can see each point is given an attribute. So lat long, depth, and magnitude. Here you can see. So this is kind of a small visualization that you could do within the notebook itself. So to create this, you need to have this kind of data. And where do we get this data? So we'll see about that in just a bit. But a broader picture is you have to install a Kepler GL Python library. So if you see on the screen, I'm installing Kepler GL. Okay, and I'm also importing pandas. So pandas is basically Excel in Python. So you can actually manipulate a lot of things in similar to Excel. When you do it manually, in pandas you can automatically do it. So, and this is just for Google Colab, nothing to fret about. So these are the two libraries that we install. One is pandas and one is Kepler GL. Once you install this, if I can run it now, it will install the library. And now I'm trying to read this CSV file. And where do I get the CSV file? Now this CSV file, I actually was able to get it from one of the Indian government websites, which is this. You see National Center for Seismology. So here you see this is Indian government website, and it has data for many years. I was fetching for 2022 to 23. I easily found it. So luckily there is a download option. You don't find download options a lot in a government website, but anyway, so I found this, and they have this column lat and long. So whenever you see lat and long, you can actually turn it into a geospatial problem and then do a lot of things. So in this case, I downloaded this. Cool. And if I try to show you this data, so let it open. So this is an Excel file that these guys provide in. Okay, so this is the data. They give the origin time, lat long, depth, magnitude, and where it occurred. Now I convert this to a CSV file by just removing this, like delete this row. Okay, and then so once I have this, I can actually save it as, you can actually do this all of Python, but it's very simple steps. So not everything should be done in Python. So you can actually save ncs.csv and change the format here to CSV, which is text. Okay. Okay, so now that I have saved it, what I have to do is I have to import that file here on this platform. You could either do it on a local machine, but I suggest if you have small data, you could actually use this. Okay, so I've uploaded ncs.csv. What I'll now do is I'll read that data. So in Python, how do you read an Excel file? You just open Microsoft Excel, right? So in Python, you do it as PD, which is pandas, asking pandas to read this CSV. Which CSV? ncs.csv. And when I read it, so the same data frame or Excel file that you had seen on the machine is visible here. Okay, so now with this, what we'll do is we are just manipulating a little bit. We are saying pandas that the time that you are seeing on this field, make it a compatible time so that pandas can understand. So that is what we're trying to do here. We're saying that the column that is there here, make it so that I'm able to understand. So this is the first part. Here, df place, which is, I'm creating a new column called place from my location column, and I'm splitting on comma. So whenever you see a comma here, I'll just show you an example. So in the second line, what we're trying to do is, I want to identify the location where it occurred. So the highlighted portion here, 24-kilometer north of Mandi, Himachal Pradesh, India, I want to pick up Himachal Pradesh from that. So that is the whole idea of doing this. When I run it, I think you will be able to identify. Now let me run this. Okay. If I run it now, df.head. Okay. So here you can see I made some modifications, and then I'm trying to display the data frame again or the Excel file. And here you can see a place column saying that it occurred in Himachal Pradesh, it occurred in Maldives, Manipur, and so on and so forth. So that was the point of this data frame. And now the important part is you can actually now directly visualize using Kepler-GL. So you just have to call, this is the syntax that Kepler-GL follows, is you call this class Kepler-GL saying that I want a map with height of 600, and it creates one map. Okay, so and then you can add your data that you want. In my case, I wanted to add this data frame, which is this, to the map. So if I run it now, here you can see I've gotten the same result after running this. So here you can see not just this, but I can also import any other data that I want from just clicking on adding layer. So there are various options here that you could do. If you don't like this Python interface for Kepler, you can actually, Kepler GL has a web interface as well. We just have to go to this website Kepler GL and then drop your files. This will be similar to what we did in Python. But if you don't want to use code, you could very well just import data here, and as QGIS does, you can then play around with the data. Cool. So that is one application that you could do. So very simple Python code, nothing to fret about. This code is also available. I'll make it available so that you can play around with it. Okay, so last thing is so we're trying to calculate. There's another application that I'm willing to show you guys. Just a minute. Okay, so now I want to show you NDVI from satellite images, and so this is one fun example that so this is like the using modern techniques. You might have not used few libraries here, but that is the whole point. So previously, say just a couple of years ago, what you would ideally do is, say you want raster data for your location, say for Bangalore, you would go online, search for the data, say on any of these NASA or ESA portals. Or so previously I used to go to Earth Explorer and then download data from here. And you might know that going there are so many data sets. It's a pain to just go and browse all of this. So now what has happened is, it's an easier way to download data. Not even download data, you can just stream data. Say that I want this data, you can just read the part of portions you want and then forget about downloading the data as well. So here I'm trying to show you few things. Before we begin, I just have to install few libraries. Again, GeoPandas, Rasterio, and PyStack client. So these are libraries that will help us do this analysis. Okay, now what I want to do is I want to analyze for a specific region. I want to calculate NDVI for specific region. what I'll do is I'll go to this website called geojson.io. You can use any other platform for this, but I'm going to geojson.io and I'll go to my region, which is Ballari. Okay, so Ballari is very famous for say corruption and also for Tungabhadra Dam, and a lot of it is for Hampi, Hospet. So all of this is very near. So I'll just go to this. Where is Tungabhadra Dam? Here it is. I'll go to the nearby area because I think here the NDVI might vary a bit because there is Hospet, there is water, and there is some hilly areas where mining happens. So I'll just I want this NDVI for this region. So the way I do it is I just go here and then select on my area. Say I'll select this region. Don't select very large. If you have enough memory in your computer, you could do that. But for this analysis, I'll just select this. Now what has happened is on the right, you see a GeoJSON already created from this website. So when I created this polygon, it created a GeoJSON on the right. What you could do now is go to your GitHub account. Let me go to say any of the repository that you had already created. Here what you could do is add a file and create a new file. So I'm trying to generate data or a bounding box for my area of interest. Just call it bbox bly, which is Ballari .geojson, and paste in the data that you had copied from geojson.io. Okay, and commit changes. I'll just tell you why I'm doing this, but just stay with me for a bit. So this is the first reason I'm doing it. You can actually visualize data on GitHub. So what I had done is I took data, I created a polygon on geojson.io, copied the GeoJSON, went to GitHub and created this file bboxbly.geojson, and it is showing me my area of interest. Now I want to calculate NDVI. So the first step is over, which is my area of interest is defined. Next step is just click on draw and then copy this link. This is the raw content from this GitHub account, and then go here, come back to my notebook and run this notebook. Okay, so now I'll explain what is happening here. We have already defined our bounding box, which is our area of interest, and here now we are trying to download our bounding box from some other location. In ideal world, maybe in our say in industry as well, nobody downloads data on the local machine. Everything is on the cloud. So that is the reason I was trying to replicate that, saying that your area of interest is stored somewhere on the cloud. In this case, it was stored on GitHub. So similarly, here we try to store it on GitHub and then download the data. So request module helps you do that, is to download data which is stored on some server. So you actually you made a request say to GitHub saying that you can you fetch me this GeoJSON, and it did. Now if I just paste this source, you will see the exact same GeoJSON that we had seen on geojson.io. Okay, so this is the exact thing that we have got. Now what we'll try to do is we have our GeoJSON, which is our bounding box or say a proper polygon. We are now trying to create a feature out of say a vector layer from that GeoJSON. So to do that, you can use Shapely. Let me run this and I'll show you what is happening. So this is what Shapely does behind the scene. So it took your geometry and converted into a polygon, which can also be visualized on the screen. So the thing that you're seeing, which is variable name as AOI as polygon, so that is a Shapely polygon, and then can be used. It's a vector layer without georeferencing. So that is what Shapely does. It defines geometries, polygons, lines, similar to what you do in QGIS. So when you open QGIS and then run it, I want to draw parallels from there. So if I just if I go to any region and if I draw a polygon here, okay, and start drawing. So this polygon and the polygon there, the difference there is this is georeferenced, the one that you see on screen, but Shapely is not georeferenced as yet for now. We can do that using some libraries called as GeoPandas. That is the first layer, which is Shapely.geometry. We have our area defined. We know that at least this is the width, this is the height, but we don't know where on earth it is. Okay, so now our main agenda, which is how do you, without downloading data, how do you get the NDVI for the area of interest you selected? So for that, we'll use something which has been built by the team at Element 84, which is a company. They have built a API. API basically is I have all the data. If you want data, just call me. I'll get the data for you for whichever area that you want. So we'll be running this URL. We'll be calling this URL using this client operation from PyStack client, and then we'll define saying that for my area of interest, which is this, get me 10 assets or 10 scenes of Sentinel-2 imagery from this date to this date. So that is as simple as that, saying that I want the data from 2022 to first month of 1st to 24th of the January. I want 10 entries, maximum 10 entries. It can, if it is more, I just want 10. And I want it to intersect with my area of interest. So if I run this search and then run this, it says that my area of interest as Shapely geometry is not multi-line, this is multi-polygon. It found 5 items. So for that date and for my area of interest, it found 5 items. Okay, and you can actually see which items it found using the search.getAllItems. So what I'm showing is the modern way, what people usually do now to fetch data. Here you can see, so I found 5 items. If you might be familiar with downloading data, you might know these the naming convention. Okay, so within this item, all the metadata, you're still not fetching the data, original data. So for NDVI, I want say band 8 and I want band 4. Okay, so for that I have these two assets and I have the reference link. So this is the data where it is stored. So it is saying that if I just run this on the browser, you see the extension, it is .tiff. Now if I press enter, right, it is same as data on a local machine. It will try to download the data. Here you can see it is 210 MB because my area is very large. I'll just cancel this. I don't want to download the entire data. Who wants to download data? But the point is the data is stored somewhere. You're just trying to access the data from the cloud without downloading. Cool. So you have 4 items. And now what I'll do is, this is just some code to convert all of that to a data frame. This is of no interest to you as of now. I just want to show you something which is will be useful for you. So now we found 5 data sets within our area of interest to calculate NDVI. And these 5 dates are 21st of January, 16, 11, 6 and 1. For these dates, we found some data over our area of interest. And we also found their EPSD code. So this is another important thing that if you don't know, it is basically Now you're defining a projection system for your area of interest. So it already, because Sentinel-2 already has a projection system in the UTM zones, but sometimes some data sets have projections in geographic coordinate system. If you don't know, don't fret. That is not an issue, but you should just keep in mind that what is my projection. Okay, so these are the things that that you could see. And now I want one of those data sets and calculate NDVI. I have 5 data sets. From that, I want to calculate one data set. I'll just quickly hurry. I'm already running out of time. So there's one ID. I can just fetch this ID and paste it here. Now here I'm trying to do is, so this is what is different from traditional thing and using it in Python. If I run it here, you can see, so I try to access the band 8 and band 4 for this asset. Now if I just show you what is inside this, it is just a link. I'm not downloaded the data yet. It is just a link to that data. Okay, so now is the fun part. So with just this line of code, you are able to calculate NDVI. And so far you have not even downloaded, and you won't even download data. Here you can see I'm reading band 8 and band 4 directly from the link and calculating NDVI on this just with this one line. Now if I run this, hopefully I'll be able to run it, because it is a huge tile, might take time. By the way, if you have any questions, I think that was the end. Yeah, so there are a few resources that I'll show you, and you can connect with me later. But as it runs, so that is the end of the. There is this one very good resource for GeoPython. You're just starting out. So these guys present at FOSS4G every year. FOSS4G, an annual conference for Geospatial. So these guys go there and present how do you analyze data using GeoPython, using Python libraries for GeoPython. So they have this workshop folder. Inside this, if you go, you'll find the Jupyter folder and content folder. So within this, you'll find notebooks. So these are all the notebooks that you can actually read. These are actually very well written. So that is why I'm suggesting. And this I'll share the entire Notion page with you later. But yeah, so it actually ran, and my NDVI is calculated. See how easy it was. And now I'll try to plot it. So there is this one command. The only thing that you have to take away is it's much simpler to do it in Python if you know what you're doing and if you have installed libraries. And it's much easier on the cloud. So now we are running is Google Collaboratory, which is not from my local machine. It's online. So here you can see, I can see this water, which is very green. No note, because a lot of stagnation happens, and this is January month we're talking about. And here you can see a lot of green cover over this. So this is one way that we could do, and now you can just play around with all the indices that you want. And yeah, so that is the end of the session. If you have any doubt, feel free to, and I'll share this. Where is it? Okay, here. Okay, guys, just see that you are able to access it. Okay, and if you have any questions, okay, Santosh. So if you have any questions, we can take them, or we can go ahead with. Just check. So a lot of you have not yet filled the email IDs. Please do. And okay, so now what we'll do is, so for this page, so we need to assign topics. So I've already selected, created this topic list so that there's equal distribution for the for each theme. Just copy and paste it here. So that is a theme. You can perform paste that must be merge. Okay. So these are the themes that we are going to work on. For some reason it is not allowing me to. Anyway, I'll keep the topic here. Okay, so you guys have access to this. Now I'll just log this. So if you want to fill the email IDs, just reach out to me. I'm limiting the access now so that no one changes this. Okay. Cool. So okay, so now we come to your hackathon. So in this hackathon, the first thing is, now because you have chosen the selected theme, your preference, and then we have chosen among them the preference, the topic, you have to come up with a problem statement as to what specifically are you going to work on within that theme, and then get it approved by us, any of the moderators, and then start working on that. So say for example, just give you an example so that clarify things. Let us go to the GitHub page. Okay, topic 1 is clean water and sanitation. So in this theme, say you're working on water quality. So within water quality, you have to be specific which area of interest you're trying to solve the problem for. Say you chose any of the dams and say Tungabhadra river, Tungabhadra dam, and then for that you have to, similarly you have to choose 3 locations. Say water quality for 3 locations. Say one dam, one say Belandur lake, or some other lake for that matter, and then there is some third optional parameter, optional area of interest that I've chosen. So out of these 3, we'll select which one you should work on, and your methodology and your problem statement is upon you. Okay, so that is the whole point of assigning each one a theme. And why we are doing this, because a lot of cases everyone will work on the same problem. If we just give clean water and sanitation, maybe everyone works on water quality. So to avoid that, only one team, whichever comes first, will be assigned that topic, and later teams have to choose a different topic. Okay, so maybe that is clear to you, and I will. This team has not is 1.5, so I'll send 1. Hope this is clear to all of you. What else? Okay, so your time for starting the hackathon is 5:30. So that is the time that we had, 5 o'clock. Sorry, that was the time that we had given. So during this time, now what we could do is, you guys have a topic selected. You guys can brainstorm and then choose a topic, choose an area of interest, choose 3 area of interest. Get back to us, any of the moderators, and then we'll finalize. So by 5 o'clock, at least you will have what problem you're working on. And if you even have difficulties finding a problem statement, do reach out. But these are the topics for you. These are the themes, and the assigned theme only is to be used, and it should fall under that category. Anything else, Santosh, or who else is on the call that we have to?
Yeah, I think we have given them clear instructions regarding the topic selection and study area selection, right, Aman?
Yes, sir. Yes.
Okay. So participants, do any of you have queries? Point number 1 regarding the training that was given to you so far from the morning. And number 2 regarding the theme which has been assigned to you. Please make sure that the theme assigned to you, you should work only on that theme. Please do not deviate from the theme. Okay. And if you have any queries, please get back to us.
And also,
Aman, now what is the next program after this? Now we have finished GeoPython.
so that is so only the thing that was left was announcement for topics. So that
Okay.
also we have done now
Okay.
via this sheet.
So
Um,
they can use the time and maybe they can start it right away. Maybe by 4:30 they can start, and we can give them 24 hours of time. Tomorrow, I think by 5 or 5:30 they have to submit. Is it
yes, sir, that
okay?
works.
Yeah.
Okay, guys. So please start brainstorming within your team what topic you have to choose, and also please select your area of interest carefully. Find for data. If you need any help finding data, please reach out.